Hello everyone, this is Mahmoud Matouk, and in this quick presentation we will have a closer look on NTR Serverless architecture on Amazon Web Services. So my agenda for this presentation is to have a conceptual discussion of the NTR architecture and the different options to implement this architecture on Amazon Web Services, and then we will have a discussion on how to go serverless, and then we will have a demo of creating an end-to-end serverless web application on Amazon Web Services. So in the simplest terms of NTR architecture, this is how it looks like. You have your backend or your data tier. This is where you keep your data, whether in a database or an ERP or any other sort of data storage. And on top of your data tier, you have your data access layer or the model layer. And this is where you provide APIs to do the basic add, update, delete operations on your data. And then you can expose this data access layer as services for your clients to use. And then in your presentation layer, you have your different client types, whether it's a web client, a mobile client, any other sort of clients that utilize your services exposed from integration layer to interact with your data. So usually these layers are translated into servers. So in your presentation, you have a web server to keep your static file and present them to the internet. In your integration and DAO layer, you have application server. You could combine them in one server or split them to different tiers, depends on the complexity and the architecture of your application. And in your backend, you have one or more databases or ERP systems or any other sort of data storage. Usually, if you would like to eliminate the single points of failure and make sure that you are highly available, you will start provisioning more and more servers in each of these layers. And soon enough, you'll find yourself adding load balancers and distributing the load between servers, and also providing the logic to identify the failed instances and to replace them, or provide self-healing strategies within your environment, and so on. Soon enough, you'll find yourself ending up with something like this, which is the gold standard for highly available environment, by provisioning the same environment in a passive mode in a different region. So you make sure that you can recover from disasters in a specific region. And definitely you can see how big the environment could be, and no matter how big or small your application, you could spend so much effort and money on provisioning such environment and keeping it and maintaining and operating this number of servers all the time. Definitely by offloading this infrastructure to the cloud, you are taking a lot of the operation complexity from your shoulders. However, you are still in some scale responsible for your servers. So generally, how would we implement these tiers or these architectures or deployments on Amazon Web Services? There are definitely a lot of options, and we can go into so much details, but this is not the scope of this presentation. So I'll just mention what are the options available. So you could utilize virtual private cloud, EC2 instances, and RDS, which is relational databases, or DynamoDB, which is the NoSQL databases, and implement your tiers manually. You could utilize something like OpsWorks, which is Amazon tool or Amazon version of Chef. And in OpsWorks, the environment is architected as layers of stacks. So you could have a layer for your presentation, a layer for integration, a layer for database, and so on. You can utilize CloudFormation, which is Amazon Web Services scripting language to script your environment creation, and you can create versions of your environment. You can utilize this to deploy multiple environments in multiple regions without going through any manual configurations. You could utilize CloudFormation to also run environment test scripts to make sure and verify the environment after installation. And with CloudFormation, you can group everything in one stack, so you can easily delete this stack if you would like to redeploy your environment, and so on. You could also utilize Elastic Beanstalk, and the Beanstalk is a service that takes your application and creates whatever infrastructure needed to make this application up and running. It hides the complexity of the environment from you. However, you are still responsible for the servers created as part of your application deployment. So to go serverless, there are many services offered from Amazon Web Services that you can utilize without running a server instance. It could look something like this. So you could utilize DynamoDB for your database, and actually you could also utilize RDS. Both of them are serverless. You don't maintain any servers behind these databases. DynamoDB is a very fast DB. It's a NoSQL database, so you don't have any complex queries or joins or atomic transactions. But if your application requires any of these functionalities, you could consider using RDS. You could also utilize Lambda for your data access layer, and this is where you go and write a function that you would like to run as a response to a specific event in your environment, and then you can create these events and attach them to your Lambda functions. And these events could be a file upload to a bucket, a record inserted in database, a URL, and so many other triggers you could use as events to a Lambda function. And then you could utilize API Gateway to expose these Lambda functions as REST services or a REST-like services. So you could have a URL to a specific function. When you trigger this URL, it will trigger your Lambda function, which will provide you access to your database. And then you could utilize S3 for your presentation layer. S3 is an object storage service from Amazon Web Services. You can think of it as a Google Drive or a drive on the cloud. And you can configure a bucket, which is the high-level container of your objects, to function as a website host. So let's get into the console and try creating an application utilizing these services and see how it goes. I will start by creating a table in DynamoDB, and then I will create a Lambda function to access this table, and then I will create an API gateway to expose the Lambda function, and then I will deploy my static artifacts to the Amazon S3. And then I will use Route 53 to assign a domain name to my website. So I will go to DynamoDB, create a table. I will name my table books, and I will choose book ID, which is a number, as my primary key. As you see, this is the only information needed for DynamoDB. It's a NoSQL database. You can later on create your records with whatever structure you need for each record. Okay, my table has been created. Now I will go to the items tab and I will create one item. So I will add a record with book ID 1, and I will add a name and author for this book. So book name is Serverless Applications. And author is myself. So this is my record and this is my backend layer. So I have created a table in DynamoDB and I have created a record in this table. And as you see, this is serverless. I don't care what types of infrastructure or servers created behind the scene for this. What I care about is that my table is available, my data is available. I can access it with the APIs anytime from anywhere, and I don't maintain any servers for that. So the next step is to go to Lambda. So in Lambda, I'm creating a new function. Definitely there are a lot of knowledge behind each of these services. However, I'm just taking a fast path to show you the end-to-end solution, and then you can definitely dig into any of these services in details to know more about it. So with Lambda, you have a lot of pre-configured templates you can start with, but I will start with a blank function. Next, I will name my function book details. This is now function for my books table. Here you can choose the runtime. I will go with Node.js, and I will just leave the default code as it is for now. The handler is fine. The rule here, I have to choose IAM rule that allows the Lambda function access to DynamoDB. So I already created this rule before, and it is just an IAM rule with a policy that allows Lambda function to access DynamoDB and allows Lambda function to assume this rule. And here, these are the advanced settings of your Lambda function. So how much memory you assign for this function and what is the timeout of this function. So I'll just adjust this to 10 seconds to make sure that it doesn't time out for me. And 128 megabytes is fine. You can definitely put this in a specific VPC if you have virtual private cloud configured for your application to make sure that it's only runnable within your VPC. Next, create this function. And I can just test this function simply. It asks you here to provide inputs. I'll just test it with the default input. And this is what comes back from the function. hello from Lambda. This is what we have configured here. So now I will change this code to actually expect an input of book ID and use this book ID to retrieve the data from DynamoDB. And you will see how easy this code looks like. So this is now the code required to run my Lambda function. Here I'm just doing some declarations at the beginning, and then I'm logging the parameter I'm expecting, which is the book ID, and I'm creating an input parameter with this value, with the value of the book ID, and then I'm using the doc client to call my DynamoDB, and I'm targeting a table with the name books, and I'm passing these parameters so it should retrieve the record that matches this input. And these are my callback functions, so in case of error I just log this to the console, and in case of success I return a JSON bars of the returned data to my caller. So to test this function I have to create a JSON structure that matches my structure here. So I will just use configure a test event here. And here's my JSON structure with params, query string, and book ID of 1, and I will save and test this. And you will see here that the input returned is the data returned from my table. So now I have my data layer of DynamoDB, and I have a Lambda function functioning as my DAO layer, which is providing the API to access my database. And then I will next expose this Lambda function as a REST service, and I will do this through the Amazon Web Services API gateway. So this is my next step, going to the API gateway. Okay, I will create a new API. I will name this books API. So as you see here, it offers you resources. This is exactly very similar to the REST structure of services. So you can add methods, and you can configure what each method is supposed to do. So I will add a resource, which is a method, a REST method, and I will name my resource book details. And then under my resource, I will enable the get function. And I will let the get function go to a Lambda function. I will select the region where I created my Lambda function, which is US West 2. And my Lambda function is book details. And here I have to configure some stuff about my source function. So I configure here query strings and how to pass these query strings to the Lambda function. So I will go to method request, and I will add some query strings. I will actually add only one, which is the book ID. And then I will configure in the integration request that I want to pass everything to the Lambda function as JSON. And I will select here to path method request path through, which will path actually everything I have in my request, including the headers, query parameters, and any body to the Lambda function. So now I have all the configurations done for my API. I can test it. Here you go, you see that it went to my Lambda function, and this is the response coming from my function. And here you can see what has been actually passed to the function. So you see that it created a JSON structure of my parameters and headers and all of the information I have in my request, and passed this over to the Lambda function. And because we have configured our Lambda function to expect the book ID in this structure, which is params, query string, book ID, then we are successful in retrieving the book ID from the pass-through request and use this to retrieve the information from the backend. So at this step, we have successfully created the API gateway that links to our Lambda function, and the next step is to deploy this gateway. In deploying the API, you choose the stage you deploy to. So you could have your production APIs running while you are testing some additional changes to your API in a test environment, and then you promote this to production whenever you are ready. So we didn't deploy anything before, so we will create a new stage, and I will name it test, and this is my test environment. And so once I deploy, it gives me the URL to my API, and I can just take this to the browser. So this is the root of my API. I have to add slash my function name here, or my resource name, which is book details. So as you see here, I just took the URL to the browser and adding the resource name, which is book details, and adding the parameter book ID equal 1, and this is the response I got from the REST method. So now we have our API gateway ready, and the next step is to deploy our static resources to the S3 bucket, which will function as our website host. And before doing this, we have to figure out how we are going to interact with the REST method here. So in our case, we are going to invoke this as an AJAX call. And for this case, I'm downloading the client generated from the API gateway for me to use in my static resources. So if you get here, you have SDK generation. So you can generate different clients to interact with this API gateway. I will choose JavaScript, generate SDK. With the generated SDK, you have a README file. And in this file, it gives you instructions on how to use the API client. So these are the scripts you need to include in your page. And then you have to create a reference of your API client. And then you have to create some parameters used with the API client. And then this is how you call different methods you have defined in this client. These are the resource methods. So in the API client itself, there are a bunch of calls, a bunch of definitions, but what we care about is the API client.bookDetails get. This is the actual resource and the method we have defined in our function. And regardless of what's written here, all of this is generated. This is how you call your API from your static resource. So here I have my static page, the HTML page that I will deploy to S3. And you can see that it's really very simple, just HTML with a bunch of styles. And then I have the scripts here, so I have to copy the scripts as advised in the README file. And then, as also advised in the README file, I have created an instance of the API client, and I have created the parameters required to be passed to this method. And actually, in getting the book ID, I'm just getting this from an input parameter from my form. And this is the function that will execute on the submission of the form. So I'm just getting the parameter, the input parameter from the form, and adding this into the JSON structure and passing this to my method. So here I have to find the correct method name as I created it. So we are good to go. We have to copy the bookstore and the API client and the library generated from the SDK to our S3 bucket. So heading to the console and creating the S3 bucket. So in my console, I am moving to S3. And I will create a new bucket. I will name it books.mserver.online. So definitely when you are creating a bucket, the name has to be globally unique. And if you would like to attach this name to a domain name, then you have to follow the same pattern that you will follow in your domain name. So I own the domain mserver.online, and I will just add a prefix of books and I will use this later on to assign the domain name box.mserver.online to my bucket. I just created the bucket. In static web hosting, I will enable this to host a website, and I will define my index resource as bookstore.html. And here you see that it generated an endpoint. So anytime I fire this URL, it will take me to the bookstore.html, and from bookstore.html I can reference anything else within the bucket. So then I will get into my bucket and upload my data. So here I have added bookstore.html, I have added API client, and I have added library. Both API client and library are auto-generated by the API gateway. And then I will start the upload. And then I will choose everything here and make it public so I can use this as a website. So now let's get to the endpoint of the bucket and see how it looks like. So this is the page I have created. It is just a simple form that asks me for the book ID, and I will here provide the book ID of 1, which matches the book ID of the record I have in database, and submit. When I submit, you see that it makes the call directly to my API gateway and passing the parameter, and I'm getting the error that cross-origin is not enabled for this URL, or cross-origin is blocked from my browser. So I have to go to my API and enable the cross-origin and redeploy my API. Books, book details, enable course, enable, yes. And you see that it by default creates an options method and makes the cross-origin enabled on it, because this is how the execution of cross-origins happens from the browser. It usually fires an options call first to make sure that the get or the post operation is enabled for cross-origin, and then it follows this with another request to the actual method when the cross-origin is enabled. So now I have did the change, and then I have to redeploy my API to the test stage. Now we should be good. If we go to refresh this bucket again and hit the number 1 and submit, here you go. It makes the call to my API and retrieves the data from the backend. I have the book ID, serverless applications, and the author name as I have created them in the backend. So the final step I would like to do here is to configure a domain name to this bucket, so I don't have to use the auto-generated domain name. I can use a more sophisticated domain name for my site. For this, I will head to the Route 53, and I already have some domain configured. mserver is already defined, so I'll just add a new record, and I will add a prefix for my domain, which is books, and I will configure this to use an alias. I will choose my bucket and create this. So now if I go to books.mserver.online, it should take me to my bucket. There you go. I'm using my domain name to get to my bucket, and if I hit 1 and submit, this returns the data from the backend. So now you see this is an end-to-end web application. It could be trivial or simple, but it's a full end-to-end application with a presentation layer of HTML with scripts and styles. So for this, you could go as advanced and as sophisticated as your skills allow you. And for the integration layer, we have REST-like service that fires when we submit our form. and it takes us all the way to the backend through a Lambda function representing our data access layer. And this hits the backend, which has been defined as DynamoDB table, and returning the data back to the UI. So definitely with this architecture, you can go very advanced. You can create as many services and as many API gateways as you wish. Definitely there are soft limits you can extend, and definitely you can manage your cost the way you want. And the good thing about this is that you are only charged for the services you use and when you use them. The only thing I would like to highlight here is the security of your API gateway. I will not get into this, but it's definitely possible to secure your APIs based on web federations. So you can use and utilize many services offered by Amazon Web Services to secure your APIs. One of them is web federation, so you can just ask your end user to log in with some of the social media accounts, and then you can use this and utilize this to get a secure token from Amazon Cognito or STS, and utilize this token to securely call your APIs. I hope this has been helpful to you, and enjoy your serverless applications.